So the first thing you need in order to find the slope of the tangent line, using specifically, in this case, the derivative definition. First you need the definition, which I have written here. F prime of x equals the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. A quick note on the notation, f prime of x just means the derivative, which is the same thing as dy dx, the same thing as y prime, that little dash means prime, same thing as d dx of f of x, same thing as d sub x of y, but these three are the ones you usually see. In order to understand this, how to use this function, I have to do an example. So in this example, we're supposed to find the slope of the tangent line at the given point. Here's our graph. Here's our given point. If you don't know what the tangent line is or what it means, see the tangent line video. Step 1, we have to take the derivative. Now, there are multiple ways of taking the derivative, but in this case we're going to be using the definition as shown up here. So this part tends to be confusing, so I broke it into 3 parts. The limit of all this is the derivative. We have our blue part, our purple part, and our green part. For the blue part, which is f of x plus x prime, I literally took x plus delta x and put it in parentheses where the x was in the original function. It was 3 minus 5x. So I just took all of this and put it exactly where x was. The purple part, f of x here, well, we were given f of x by the problem. That's part of the problem, so we didn't have to do anything with that. That just is the function, 3 minus 5x. And the green part, delta x, simply is delta x. A quick note on that is delta x is one thing, not two. It's not a delta times an x. Delta x is one variable. So the next step is to continue taking the derivative by plugging in all these parts. So remember, we had our blue part, which we found right here. So I stuck it here, blue part, minus purple part. So I just stuck the purple part in parentheses. Don't forget to put the parentheses. Exactly where the purple part was here from the definition. And then put it all over delta x just like it was in the definition. Again, we took each of the 3 parts we got and just plugged them in. So now that we've got this, we can state that our general goal is to eliminate delta x from the denominator, because as we can see, delta x is going to 0, and if you took this limit the standard way and just plug 0 in everywhere you see a delta x, you would end up with a 0 denominator, which can't happen. So right now our goal is to get that out of the denominator. So then we do that by, well, first simplifying what we have up here. So we have, I wrote it down here, 3 minus 5x minus 5 delta x. So I just distributed this negative 5 here and here. And then minus 3 plus 5x. I just distributed this negative to both the 3 and the negative 5x. So then we cross everything out that we can. Positive 3 here, negative 3 here, they cross out, negative 5x, positive 5x, and you are left with the limit as delta x approaches 0 of -5 delta x over delta x, which, lucky enough, cancels out. So in our case, we're left with limit as delta x approaches 0 of -5. Now the limit of any constant is just the constant itself. If there's nowhere to plug in the x or delta x here, we just don't do it. The answer is -5. So again, the limit of a constant is the constant. Why did we get a constant? Well, if we look at the graph here, if we graphed the function, it's a straight line, and it looks pretty much like that. Maybe a little bit steeper, but that's approximately what the line looks like. It's a straight line. So that sort of leads into the point, what about the point given? In the original problem, it said at the given point, and it gave us a point here. Well, in our case, it didn't end up mattering because the slope is constant. No matter which point on the line you take, the slope is going to be the same. So whether it's this point that they gave, or that point would be about there-ish, whether it's this point or a different point or any point on this line, the slope is constant because it's a straight line. Now in more complicated problems where you have curves and the slope it's constantly changing, the point will matter. But in this case it was a constant, so it does not matter. So the answer to our question, find the slope of the tangent line at the given point, is -5. The slope of the line, or the slope of the tangent line, at any point on this graph, including the given point, is -5. Slope equals -5.